Hi everybody. So today's video is going to be about task 1.8, which is the 8th task of Module 1 for Math 1. In today's video, we have two learning targets, and they're the same learning targets we've actually been looking at for the last two videos, only today we're going to focus on a little something different. Instead of focusing on creating explicit equations for both arithmetic and geometric sequences, we are going to be focusing on creating recursive equations for both arithmetic and geometric sequences. Here's the idea behind a recursive equation, which is a different way of thinking about this pattern. The big idea is that a recursive equation is always based on the previous term. Now, when we say previous term, it means instead of being able to find a pattern that works for any input you want, it's a pattern that only works if you're just trying to find what comes next. So all we are going to ask ourselves for a recursive equation is what comes next. With explicit equations, we were able to predict what happened way in the future or, beyond the edges of the table that we had. What we're going to do with recursive equations is just predict what comes next in the pattern, not what comes anytime in the future. So a recursive equation is always based on what's called the previous term. Before we fill in the notation components here, I want to show you what I mean by the previous term. You're going to recognize this prompt. It's actually from the same one that we used for task 1.6. It says, Diana starts the year with 10 demon dollars and earns 2 demon dollars each week. Now, it's the same pattern we saw before. She is starting with 10 demon dollars and she's earning 2 demon dollars each week. So if we were to read this table, the pattern would just be plus 2 every time. Now, when we wrote an explicit equation, what we were doing is saying, okay, for W, whatever number you want to pick, you could pick 10, 11, 12, 95. How could you plug that number in and predict the number of demon dollars? For a recursive pattern, you are going to reuse the numbers you have and just write what comes next. So here's what I mean by that. If I were to write this in a slightly different way, I would just say that the first value here was 10. Now the next value is 10 plus 2. The next value, instead of saying that it's 10 plus 2 plus 2, we're going to say that it's 12 plus 2. So you're always going to reuse the previous number. So if this one was 10, the next one is 10 plus 2. If this one is 12, the next one is 12 plus 2. For the next number in the pattern, we would say that the next one would be 14 plus 2. You're always using the previous number. Now, here's what that looks like with variables. If W is what I'm interested in, if I'm interested in a certain week, I'm going to call it W. The previous week would be what we call W minus 1. Because to show that it's 1 before that, we would show we were doing W minus 1. The next week would be what we call W plus 1. So if this is W, then the number before that would be take away 1, and the number that comes after that would be plus 1. Now to represent the outputs, we would say D of W here. To represent this output, we would say D of W minus 1, because the input here is W minus 1, so the input here is W minus 1. And to represent the output here, we would say D of W plus 1. Now, that looks a little bit different, but really it's just this is the output for this week, this is the output for last week, and this is the output for next week. If we want to represent the equation this way, we would say this week's output would be equal to last week's output, so D, because it's the output, from last week, W minus 1, which is the same thing we can see here. This is last week's output. I can kind of draw an arrow here to show you where that's coming from. You're using the last week's output plus your pattern. You'll notice that we always take last week and add 2. So we would just take last week and add 2. This right here is what we call a recursive equation because we are reusing the last value, d of w minus 1. Take the last output and add your pattern or multiply by your pattern or divide or subtract or whatever. Here's some of the notation you need to know. When we're talking about the current term, so what we're interested in right now, we would say that the input would be x and the output would be f of x. When we're talking about the previous term, so what happened last time in the pattern, we would say that the input is x minus 1 and the output would be f of x minus 1. You'll notice that the f on the outside is what makes it an output, and no f on the outside is what makes it an input. If I were to say write this recursive equation, it would be the output. Let me write this in words first. I think that would actually be better. We would say the current output is equal to the previous output plus 2. Because that was the pattern in this table, that it was the previous number plus 2. To represent the current output, we would say d for output of w, for the number that I'm on now, w is where I'm at now, is equal to the previous output. So again, the word output here is what tells me to put d of the previous would be w minus 1 plus 2. This equation is translated from those words. Now here's the thing about a recursive equation. Because it's all based on the previous number, you have to start somewhere. So in addition to specifying the equation, we also need to specify what number to start with. We call that the starting value. So this equation has 2 parts, the actual equation and also the starting value. Now, based on this table, the starting value was input 0, output 10. So I would say d of 0 equals 10 as the second part of my answer. And we need both parts in order to have a complete answer. Now, part of the reason for this is because if we just say start with a number and add 2, all of your answers change depending on your starting number. For example, if this started with 11, all of the following numbers would be different because we started with a different number. So because everything for a recursive reuses the numbers you already had, we need to specify where to start. Let's go ahead and generalize our solution here. So writing recursive equations. A recursive equation always has 2 parts. It has an equation which will always relate each term to the previous term. And we're going to be looking at the output related to the previous output. And that means that we've got previous means we're going to put a minus 1 for the input. We also need a starting term. So if your pattern is going to be multiply by 3, then we need to say multiply by 3 starting with something. You'll notice that we do not mention here that we need to get back to 0. If we looked at tables with explicit equations, we talked about how if your table doesn't start at 0, you need to get back to 0. With a recursive equation, you do not need to do that. It is not necessary to adjust the equation when the table does not start at 0. And the reason we don't need to adjust is because we're going to tell that the table doesn't start at 0 by listing the starting term. We don't need to do that in the equation. We're going to list it separately. What that means is that every single recursive equation will start off the same way. Every single recursive equation will start off with f of x is equal to f of x minus 1. It will always be minus 1. There will always be an f here and an f here because now we've got outputs. Unlike our previous examples with explicit where we did not have two outputs in the same equation, now we've got two outputs in the same equation. And then you're going to have plus, minus, multiply, or divide by whatever pattern you find. So here's how we might do this. With an arithmetic sequence, for example, if I saw a table that said 0, 1, 2, and then 5, 8, 11, the first thing I'm going to do is look for my pattern. My pattern here seems to be that I'm adding 3 each time. So for my recursive equation, if I were to say it with words, I could say that the current term is equal to the previous term and then plus 3. To say this with symbols, I would say f of x is equal to f of x minus 1 plus 3. Now that's part 1. We wrote our equation that relates the current output to the previous output. We also need to specify the starting value. So where do we start? We start with f of 0 equals 5. When the input is 0, the output is 5. Both of these are necessary in order to have a complete recursive equation. Now for a geometric sequence, I might start like this. Let's look at this pattern. It looks like I'm dividing by 2 each time, which I'm going to change to multiplying by 1/2. Because I'm not allowed to use division in equations. I'm not going to write out all these words again. I'm just going to skip straight to the notation because I know that it's always going to be f of x, the current output, is equal to the previous output, f of x minus 1. So it's the output for the previous term, one before that. And then I would use my pattern, times 1/2. You'll notice the only difference between this equation and this one is the pattern at the end. Every recursive equation is going to start the same way. But I also need to specify where to start. So I'm going to say f of 7 equals 100. And again, I need both parts of this equation in order to have a complete recursive equation. Now again, the common mistake here, unlike explicit equations, the starting x value does not change how we write a recursive equation. I've said it twice now. I made us write it on our own, and I actually wrote it for you here because that's really important. That's a common mistake that I see that students make, is that they want to change this equation. So for example, when this says 7, they want to change this to x minus 7. We never do that with recursive. With recursive, it's always current and previous means 1 step back, not 7 steps back. The only time we need to adjust is if it's an explicit equation, which is a little bit different. All right, let's try this. A cafeteria has free lunch tickets to give away to students in good standing. On week 3, the cafeteria had 35 tickets left and gave away 5 each week. If we've got this table of values, we can see that week 3, we have 35 tickets. There's our starting value, which we could see in our words as well. And we give away 5 each week. So I'm noticing that the pattern is that we're subtracting 5. Now, because I'm asked to write a recursive equation, so you'll see it says here recursive equation. I'm going to start off with T of W, which tells me that T of W equals that the next thing in the equation is going to be T of W minus 1, the previous output. So every number in this column is the previous one, and then what's the pattern? Subtract 5. To get this output, take the previous output and subtract 5. The only other thing I need to do here is specify the starting value. So T of 3 is equal to 35, and that's my recursive equation. Let's try another one. Your YouTube channel begins with 17 subscribers, and each day the number of subscribers triples. So begins with 17 subscribers. We can see that in the table where the first row has an output value of 17, and each day the number of subscribers triples, which we can see in the table by looking at the pattern here is that we're multiplying by 3. So if I want to write a recursive equation, that means reuse the previous term. So any output S of X is going to be the previous output, so S of X minus 1, the one before that, and then times 3. We also need to specify the starting value, so S of 0 is equal to 17, and you're done. Next, your friend wants to test your math skills again. They create the table below. Now, based on this table, I'm going to start by just trying to figure out the pattern. So if I look at the numbers in the pattern, we've got 900, 300, 100, 33.3. It looks like the pattern is going to be divide by 3, which I'm going to change to multiplying by 1/3. Now the starting value in the table is 2, 900, and it says write a recursive equation to model the function represented by the table. So that means reuse the previous term. Recursive reuses. So I would say f of x, my current output, is equal to my previous output, so f of x minus 1, and the pattern is times 1/3. Now I also need to specify my starting value for a recursive equation, so I would say f of 2 equals 900. And I'm done. Now we've spent quite a bit of time talking about both explicit and recursive equations, and one of the things you're going to be asked to do with this information is to generate the sequence. So up until now, you've always been given the pattern and asked to write the equation. Now we're going to be giving you some information about a pattern and asking you to write the pattern itself. It says, given the following equations, generate the first 5 terms of the sequence, starting with f of 1. So let's say that you were told that the first term is 35 and the common difference is minus 5. Well, if the first term is 35, it tells me that in this list of terms, I'm going to start with 35. If the common difference is minus 5, it tells me that to get the next number, I should subtract 5. So I would get 30, and then I would continue that pattern, which means I would get 25, and then I would get 20, and then I would get 15. If I was told that the first term is 20 and the common ratio is 3, now the first term is 20, tells me to put a 20 here. Common ratio means we need to multiply, because a ratio goes with a geometric sequence. So this time, to get to the next term, I would multiply by 3, which would give me 60, and then multiply by 3, which gives me 180, and then multiply by 3, which gives me 540, and then multiply by 3, which gives me 1620. Now, what if you were given an equation instead? So if I was told that my explicit equation is 3x plus 4, first of all, I know that this is explicit because it does not use the previous term. See how there's just an x here and not an f of x? Versus if you look here, you've got f of x and f of x minus 1. That would have to be recursive. So an explicit equation does not use the previous term. Now, for an explicit equation, to figure out the numbers, I need to be able to plug something in for all of the x's here. So it tells me in the instructions, start by plugging in the number 1. That means that to figure out the first number here, I would take this equation and I would plug in the number 1 instead of x. Now, if I type that into my calculator, I should get 7 as my first number. To get the next number, I would plug in the number 2 instead of my x. And when I type that into my calculator, the next number would be 3 times 2 is 10 plus 4, 3 times 2 is 6 plus 4 is 10. Then to get the next number, I would plug in the number 3. Which gives me 13. And to get the next number, I would type in the number 4. Which gives me 16. And to get the next number, I would plug in the number 5. Which gives me 19. I can also check my pattern because I can just make sure that there's the same pattern every time. So to go from 7 to 10, I'm adding 3. To go from 10 to 13, I'm adding 3. 13 to 16, I'm adding 3. 16 to 19, I'm adding 3. So that makes sense because the pattern is the same every time. This is going to be an arithmetic sequence with a common difference of 3. For an explicit equation, if I'm looking at this equation right here, I can tell that this is a geometric sequence because there's an exponent, and it's again explicit because it does not use the previous term. So same for both of these. Just like before, to figure out the value of the term, I'm just going to plug in my number. So I'm going to take 4096 times 1/4. And first, I'm going to plug in the number 1 here, which if I type that into my calculator, I'm going to have 4096 times 1/4 to the power of 1, which is 1024. That's my first value. And then for the next number, and I'm running out of space here, so I'm just going to give myself a little bit extra space by moving down, I would plug in the number 2. And if I type that in on my calculator, I get 256. Then for the next number, I would plug in the number 3. To the third. And if I type that in on my calculator, I get 64. For the next number, I'm going to type in the number 2. Which if I type that in on my calculator, I should get 16. And for the last one, I'm going to type in the number, I'm going to type in the number 4 here. I don't know why I just said 2. I'm going to type in the number 5. And when I do that, I should get 4. So when you have an explicit equation, the best way to figure out the numbers in the sequence are just plug in the input values wherever you're supposed to start. If this had said starting with f of 0, then instead of starting by plugging in 1, I would have plugged in 0 first, and then 1, 2, 3, 4. Now, if we've got a recursive equation, we have a slightly different problem because for a recursive equation, there's no plugging in. You just have to use the pattern. So what this recursive equation says is that to find my new number, take the previous number and subtract 8. Now it also gives me a starting value. So I'm going to start with 200 as my output, and I'm going to subtract 8 each time, which means I get 192, I get 184, I get 176, and I get 168. Now in the next recursive equation, instead of subtracting 8 each time, I'm going to multiply by 3. And I can tell that because that's what comes after the previous term. So to get the new term, take the previous term and multiply by 3. And I'm going to start with 5. So if I multiply by 3, I get 15. Times 3, I get 45. Times 3, I get 135. And times 3, I get 405. Okay, thank you guys so much for watching, and I hope that I get to see you soon.